What's up, guys? This is Siren with Startup.Security. And in this video, we're going to be talking about SMB enumeration on ports 139 and 445. That's NetBIOS SSN, alongside how I would go about enumerating SMTP, that is Simple Mail Transport Protocol, on port 25. In addition, and as a little bit of extra bling, one of my favorite exploitations of misconfigured services is NFS, or Network File Share, on port 2049. In addition to enumerating that service, we're also going to exploit the hell out of it, and we're going to have a lot of fun with it. So stick around, and let's go ahead and get started with ports 139, 445, SMB enumeration. We have our cherry tree open, and we can scroll through this. Looking down at ports 139 and 445, I'll highlight those. Here's that NetBIOS SSN, and that is Samba. So on Linux, we have Samba. On Windows, we have just plain old Active Directory and server message block. Back in the old days, if you really want to impress your professor one day, you can tell them that SMB, or SMB protocol, was once called CIFS, or CIFS, short for Common Internet File Structure. But here we have our, Common Internet File Structure, or SMB. It's been around for many, 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 many years. And we also even got back confirmation of the target operating system, or the underlying operating system, being Debian. So with that, guys, let's go ahead and get down to enumerating ports 139 and 445. So the general idea, or the general concept behind NetBIOS SSN when we're doing enumeration or Active Directory, is that there are really two types of enumeration when it comes to Active Directory, or when it comes to SMB. And those two types are both privileged enumeration. That's like I've landed a foothold in the network, and I'm ready to start doing Active Directory enumeration and SMB enumeration across a network, right? But that requires a real Windows user assigned to a real Active Directory group. We're on the outside looking in. So this would be, everything we're doing here would be referred to as unprivileged server message block, or Common Internet File Structure enumeration. And we are looking to target a couple of things. One, what shares are running here? So beneath 139 and 445, what shares do we have? That's the question we got to ask ourselves. What shares do we have? What shares are available to us? Additionally, we can check on versions. We could say, what version of SMB are we working with? Version 1 or version 1, version 2, SMB 3. In this case, it looks like we're working with SMB 3.x through SMB 4. But what's the protocol? And I want to teach you guys a couple of things. So there's a couple of ways about going about enumerating SMB. And what we're going to do is use Nmap. So we're going to say Nmap -- script. Actually, let's do this. Let's say -p139, 445 -- script is equal to SMB enum shares. And then we're going to say it 192.168.1.23. It's going to be different for you. And that's it. That's really it. We just want to run that script on it and enumerate the shares. And once we're done with that, let me exit out of this terminal. We can bring that data over with us. So we just right click, copy it, and underneath our enumeration for 139.445, we're going to drop it right in. Phew. So that didn't take long at all, right? we have an admin share, we have an IPC share, and we have a print share. I know we have other ones, but I want to say something. So the IPC share, the admin share, and the print share are generally like they're the factory defaults for server message block or Active Directory. These are the three that are going to exist no matter what. You can even go into Windows, open a command prompt, and type the command you would type in if you wanted to on your Windows machine. You could just type in net share, and you would see the same ones. Now they're protected, at least they should be with the default Windows configuration. But what are we looking for as ethical hackers here, as intruders? What are we looking for? We're looking for other shares or the ability to write to something like the IPC share. Now, I highly doubt we're going to be able to write to an admin share. That would be ideal. But, you know, sometimes we can get in with an SMB null session and list things in an IPC share. Sometimes we can't. In this case, though, we have opt. That's interesting. And we have temp, right? We have that as well. So we have two shares, you know, with a comment that says, oh no's. And a comment up here, no comment on this. But yeah, we're doing pretty good here. And that was like, you know, 2 seconds of just running the -- script is equal to SMB enum shares. So there's a little bit more. That's if you want to get back, you know, that SMB enumeration. What if you want to get back a little bit more? We're going to say, I want to put a $ here and say SMB Enumeration Continued. Okay, so everything beneath this is SMB Enumeration Continued. Because we're going to have a lot. Why so many $? Because we're going to have a lot in between these. So here we go. And do remember to save your notes. Always remember to save your notes. So let's go back and let's actually just drop down here what's interesting to us. Well, we have \opt and we have \temp. Those are really interesting. So yeah, definitely ones that we want to take a look at. Next, we have enum for Linux. So I'm going to this time I'm going to export my IP equal, or the target IP equal to 192.168.1.23. And then we're going to type enum for Linux -a, or we could just type enum for Linux vanilla at the target IP. And it's really that simple. As long as SMB, excuse me, but as long as SMB null sessions are permitted, then we're going to be able to get back all kinds of great information. So that is the case here. What are we looking for with, what are we looking for? What are we looking for with enum for Linux? Or manual enumeration with SMB client? And we're looking for something known as an SMB null session. We also want to make guest checks, that is guest credentials. That's going to be something like guest with no password, right? So guest credentials, SMB null sessions, and I encourage you to look up guest credentials. In fact, I'm gonna try and see if we can connect. Now this is a lot of enumeration to get back. Look at this. We're getting back accounts from the target machine, services, Metasploitable. We're getting back quite a lot. But this doesn't actually do any exploitation for us. So this is a lot of really good enumeration. A lot of good stuff here. In fact, I'm going to copy all of it. If it will let me scroll, there we go. And we're going to put it in a separate file just called SMB Enumeration for the machine. If I could scroll up here, that'd be great. All right, we can't. We'll get the other bit in a second. The point is, let's create a new note. add subnode and call this SMB Enumeration. And we'll put that right beneath our primary. And select everything, give it that black backdrop so it stands out. And then we need that little bit of extra up above here. Just this here, target information. And yeah, bada boom, bada bing. So we get back all of that information. There is additionally a manual way of doing enumeration. So again, we're checking for SMB, null sessions. What does that mean? You know, what is that? That means user is equal to this, password is equal to this, which means nothing. It means user is equal to nothing, password is equal to nothing. And we can use something like SMB client to connect. Now let's say I don't remember the syntax. Let's say I don't do that. Well, let's say I could type SMB ref. Unfortunately, I don't have that here with me. But nonetheless, we could type SMB client. And let's say SMB client at / / 192.168.1.23. And we could try the IPC share. And then say no credentials. Like we just want to check for null sessions, and that is it. Anonymous login successful, and we can type dir for directory, but we do have a network status access denied, so unfortunately we can't list out anything there. But we could definitely execute these commands. Like maybe, I don't know, list connect or u times, and we could get back other types of information. But let's try one of those shares that we did have the ability to access. Like what about opt? Anonymous login successful, and then bad network name. Let's try that opt. All right, what about temp? Okay, TMP worked. Oh, nice. So not only did TMP work, but we're also able to read the files in temp. Excellent. Excellent, excellent. So we have a remote machine that is running Samba, Linux, and we also have the ability to log in with no username and no password. And I really do want to demonstrate kind of what I'm talking about here. So I've got this command. Here's a full thing, a full command with SMB client 192 with parentheses included, 168.1.23, and then the share we had was TMP. The username, let's try guest. And the password, we're going to leave that blank. We're going to check for guest credentials. I'm going to drop the workgroup portion. And that's going to say NT status logon failure. Let's try guest guest. What about guest guest? Guest guest. The point is we don't have, it looks like guest credentials there, but we can keep trying. We don't have to give up. We could say IPC star, guest guest, NT status logon failure, guest guest. So the point is, when you're doing these, make sure in the modern day that you're checking for guest credentials. But in general, the one you want to look for is going to be this. Username of guest and no password. What about the admin share? Can we log into the admin share as a guest? No. Can we log into the temp share as a guest? No, we cannot. But we are permitted with, oh, I can show you this visually. Here's a null session visually. Look, user, no user, no user, password, no password. And we'll connect to the temp share. And we're connected. See? So that's a little bit more visual of what we're doing here. But just in general, remember this one for null sessions, and remember this one for guest network checks when you're doing your Active Directory enumeration. And this is unprivileged AD or SMB. You could think LDAP, lightweight direct access protocol, guest checks, and null session checks. That's just the way I think of things, right? So those are the things you want to check there. So we've ran enum for Linux, and we got back quite a bit. This time, let's drop an MSF console and open the Metasploit console and see if there's any exploits for SMB. Let's take a look at our enum here. Just going down the list, and it seems our OS version is 4.9. Okay, that's good. Scrolling down, see if we can get more information on the protocol. Looking through things. Here is a lot of good stuff. There's our temp, there's our opt, there's a comment on the share, and so on and so forth. But yeah, so that's like all done. What we're gonna do now is search for SMB, or let's search for Samba. Like, look, I can search for SMB and we're gonna get a lot back. A lot of server message block stuff back. Like a metric crap ton. Well, let's clear that out and search for, I don't know, Samba. That shortens the list quite a bit. And we are doing Samba enumeration here. There's trans open, LSA trans names heap. One that I am particularly looking for is known as the Samba symlink traversal. And that is 24. So I'm going to type use 24. We're going to type options. And we're going to set the remote host to 192.168.1.23. The R port is already set. The remote port is set to 445. And it does say it needs a target share. Let's set the target share. We had a lot of good luck with the temp share, or /temp. So, or /temp, however you want to think of it. We had access to the temp share. So let's try set SMB share to temp. And smash the return key. Set verbose to true. Good habit to get into. And then go ahead and type run. And this one now is saying, now access the following. Okay, cool. So connecting to server, trying to mount the writable share temp, trying to link the root file system to the root FS, now accessing the following share to browse to the root file system. And we were able to do that with Metasploit, but we can also do that manually. Nonetheless, let's take a look. Let's exit out of this and see what, or actually I'm going to open a new terminal. Let's cd to temp and then root. Let's cd to temp, list out everything. And maybe it was cd.fm. No, it's not here. So even the Metasploit module doesn't seem to be working as intended. This is just an example of what I'm talking about. But what we could do is, let's try this. Maybe, we have temp root FS, right? What if we try and access the share? So let's do SMB client like we were using before at 192.168.1.23 / temp with no credentials provided and anonymous login successful. We can type directory and look at that. We now have access to the root file system. And if we try and cd to root FS, you guessed correctly. We have access to the root file system on the remote machine. Excellent. Let's cd to the etc directory. And let's say we want to get the password file. getting the file, and then we can type exit. And if we cat the password file here in our local directory, and this is the temp directory on our machine, not a remote share, but we cat password, and look at that. We've gotten the password file back from the remote machine. Excellent. I'm going to go ahead and remove that file because I want to show you another way of doing this. I'm going to cd to the home directory. And, well, actually, I think that's good. That is an excellent way. We've got SMB client. We have exploited the symlink traversal, and we've got enum for Linux, and we know about guest credentials, and we know about null session checks, and we know about shares that are writable versus shares that are not writable, and we know about the default admin, IPC, and print shares, and we know about the types of shares that we want to look for, like opt or the TMP share, or these are just custom content like type of shares, right? So in this particular case, we have read-write access, read and write access to that temp share. So that's it there for ports 139 and 445. And that is definitely like 100% the foundation of what you need to know about some of the most popular ports in penetration testing, which is NetBIOS SSN. With that, we're now ready to move on to enumerating SMTP, or the mail service. So I'm going to exit this. We're going to bring it back to one terminal. And if we do an nmap of -p25 at the target IP, we will see that it is open, SMTP service. Let's tack on -sv with that. And we have postfix SMTPD. Excellent, excellent. And if we tack on -sc for simple scripts, we see that we can run the vrfy, eturn, start TLS, enhanced status codes, 8-bit time, dsn commands, and we get all of this other juicy information along with it, right? So the one we're interested in, as you've seen me talk about before, is vrfy. And you guys remember, we used Netcat to the target IP on 25, and we connected and typed vrfy root. And that came back saying 252.2.0.0 root. And then if we try and type, I don't exist, a user that doesn't exist, then we already have what's known as a username or an error-based message or an error message username enumeration. So by this error message being different, we can infer that the root user exists on the target or remote machine. So that's with Netcat. But suppose I can't use Netcat while in an engagement because it's not as effective. There's got to be another way, right? I mean, there's got to be another way. There's got to be. There's got to be another way. There is. There is another way. In this particular case, we're going to use SMTP-user-enum. And you can hit the return key on that. And here are the examples. Here is how you use the SMTP user-enum binary, or user-enum executable. There are 4 ways of doing error message username-based enumeration, or error message username enumeration on the SMTP protocol on port 25. There are numerous amounts of ways of doing this. The most popular one, verify. But I've encountered machines that don't have verify. They try to throw you a curveball, right? And they'll hit you with like RCPT or EXPN. And in those cases, now you know, you can use SMTP user-enum along with a list of users or a specific user. And you don't just have to specify one IP address. What if you're in a Class C range like 192.168.1.0 through 255, right? What if there are several machines in an engagement that are running SMTP. Netcat is not as effective. So we can use SMTP user-enum and then specify -T. -T. This means targets from a file. All within scope, as long as it's within the target scope. Let's get down to doing that. So what we'll do is we'll say SMTP user-enum, and we'll say what modality? Well, that's VRFY. We're going to say verify -user root and -lowercase t 192.168.1.23. Nice. We got one result back. I'm going to cd into my own personal temporary directory, not to be confused with TMP, but TEMP. And we're going to cd in there, and we're going to touch users.txt. We're going to nano users.txt. We've got root in here. Let's put in admin. Let's put in MSF admin. I don't exist. Something else. Blah. And that's good. Just some basic. The basic principle here is that this could be an entire list of potential users on the target machine. So let's go ahead and up arrow a little bit. And this time, instead of -lowercase u for a specific user, we'll specify -U and then punch in users.txt. And now target count was 1, username count was 6, and we got back 2 results. That means at least 2 of those users, root and MSF admin, exist on the remote machine. Nice. So that's going to pretty much conclude SMTP enumeration. With that being said, we're now ready to move on to port 2049, or exploiting weak NFS configurations. Port 2049. The principle behind NFS is that it is short for a network file share. It's a network file share. It's like taking my little temp directory here and making it accessible on the network so that anybody could come in and they could, mount that share as a drive, a network with the type of NFS, a network file share, and then essentially traverse directories into it, as I will demonstrate shortly, and grab that file. Well, if we do an Nmap of port 2049 at the target IP, we see that it's open. If we tack on a -SV for service version, we'll let that go for a minute. And we have, sure enough, 24 RPC, service NFS. And we could even tack on -SC for simple scripts, and in so doing, maybe get back a little bit more verbose information. Unfortunately, we didn't get anything back. That's okay. I'm going to show you guys how we can get back our own information on our own here. So what we're going to do is use a binary called rpcinfo and another binary called showmount. These are the two that are critical. And let's say I forgot about this. Do I want to open a web browser and have to look for it? No. I can type rpcref and boom. This is exactly what we're going to be doing. So I'm going to have this up over here, and I'm going to say, okay, yeah, I'm in an engagement. I found ports 2049 open. rpcinfo-p at the target IP, and there we go. We have a whole lot of information back. So just looking at this, we are seeing lots of network file share information and mount daemons. Remember, this little d on the end is just short for a daemon, like a service that's running, a mount daemon or service. And then we're also going to say, okay, then show mount -e at the target IP. Aha! Excellent. Check this out. So we have export list for 192.168.1.23, and then root. That's the root file system all. This could be /home/Kali/temp, like I was trying to explain earlier. This little / here on a misconfigured machine somewhere in the wild, like in one of our engagements, could be /home/Kali/temp. In this case, though, it's the root file system. So if we mount this correctly, we should expect to get back the root file system. Let's go ahead and do that. First things first, I'm going to say mount. We're going to make a directory for it. We're going to say make dir temp, and then, I don't know, we'll say /temp/siren. I just want to make this abundantly clear that it doesn't matter what our directory that we end up making. It doesn't matter what it's called. That's why I call it siren there. It doesn't matter what it's called. Make dir temp siren. And then we're going to mount -t, as you might guess, for type, -type NFS at the target machine, 192.168.1.23, colon, and then where? What did we have access to? Was it home Kali temp? Or was it /? Dude, it was /. The root file system. So / and then / where are we gonna mount that? Well, let's make it /temp siren. So we're gonna kind of connect this directory, if you want to imagine like a rope. We're gonna make a network, establish a network file share connection between this actual directory on our attacking machine and the root file system that's being served on the remote or target machine. So we're going to go ahead and actually, to do this, we might have to be root. Let's switch user, sudo switch user, and I'm just going to punch in my password here. I can punch it in correctly, and then we're root, right? Now we're going to, let's try doing a mount operation. -t NFS at 192.168.1.23 : where to /temp siren, and hit the return key. And there it is. It created a symlink. Remember that exploit that we did from 139 and 445? Do not get it confused. It is not the same port. It is not the same service. It is not the same language. It is not the same protocol. But we have created a symlink. So we're doing almost two different types of symlink traversals here. One is for server message block. The other is for a network file share. So that mounted successfully. Great. What's the next steps? Well, I can just refer to my reference file here. The general modality of exploitation is, can I add my own SSH key? Can I create my own SSH key, add it to the authorized keys file, and then just SSH in? Well, we're gonna go ahead and give that a try. So we're gonna type SSH-keygen, and then we're gonna specify the type of the file is RSA, and then -B2048. And I'm just gonna I'm gonna overwrite my existing. You may just have to keep hitting enter. You may not have one, and that's fine. But what we have is, the key is redmart image, and then, we have all this pretty stuff here. The point is that we have a key now. And if we cd to the home directory which would be /root cd.ssh, and list everything out, we have an ID RSA, because we specified type of RSA, and an ID _RSA.pub. If we were able to steal a target machine's ID RSA key, there's a very high probability we could just SSH-I ID_RSA as a user at a target IP and SSH in that way. But do remember that if you're on Kali Linux and you're getting SSH errors, we need our SSH to match. So I'm going to cat the config file in here, and this is going to update the host key algorithms and the public accepted algorithms. You may not require this, but if you're watching it and running into errors when you SSH in, just remember to create that config file and your .ssh directory and make it have these values. Well, minus the IP address, your IP address, or the target IP address would be different. In fact, mine is going to be different. The target machine is .23. So I'm going to clear that out, and we've generated an SSH key. And here it is, idrsa.pub. Now, what we're going to do before we do that is we're going to switch users. I'm just going to switch user. And we're going to go to temp siren and list it out. Look at that. That's not our root file system. Well, it is now, technically. I mean, now we got it. It's, if you get my drift. This is the target machine's root FS, but this is the root FS of the target machine, or just /. So we got that. And we can cd to the home directory there. Look at that. The FTP user, MSF admin, service, and user. What about MSF admin? And we can list out all the files in the MSF admin directory. So we've mounted from a network file share on port 2049. Port 2049. I'm going to copy these commands that we used. All we did was make a directory. All we did as the user root was make a directory called temp, SIREN in this case, and then mount that as an NFS, or a network file share. And instead of x.x.x.x, we had 192.168.1.23. That's all we did. That's all we've done. And because this was a weak, this is exploiting a weak NFS configuration. Weak NFS configurations. This is exploiting weak NFS configurations. Now I'm going to exit out of this terminal, and we're going to actually exploit it to get a shell. So I don't want to just be able to traverse and get files and maybe write files. I want to be able to get a shell on the machine. So we're going to write a file to the target machine that gets us a shell. What file could we use? What about that idrsa.pub? Now we're thinking. Let's copy, or let's cat idrsa.pub, and then we're going to append that. Remember, you need a second arrow. This will overwrite the file entirely. This will append to the file. So /temp siren, and then from here we are in the, from this / we are in the root file system of the target machine. So we want to go to the root directory of the target machine .ssh, and we want it to go to authorized keys. Again, temp siren, that's our thing here. I'll highlight this, and then /root.ssh authorized keys is the absolute path on the remote machine via a weak NFS configuration, and we're gonna write to that file no problem. And then we're gonna, from this point forward, it's actually quite simple. We're going to SSH in. Well, let's unmount. Let's be proper about this. We've written the file. Now let's unmount that drive /temp, or that share, excuse me, /temp siren. There. Now we're not leaving it out in the open. We've unmounted it, and it's done. It's really just as simple as typing umount /temp/siren, right? And then we're going to SSH as root at the target IP, and name or service is not known. Okay, so it didn't like that, but what we could do is export the IP as 192.168.1.23, and let's try that again. And yes, and we have a shell. And that is exploiting port 2049 weak NFS configurations. Nice. Another way of exploiting things, or another way of doing things, if you ever wanted to, is we could copy the bin-binary. Let's actually go back to our temporary directory. You could cd at home and then cd into the temp directory that we created, or a temp directory. Let me make sure there's nothing in it. It's all good. And then we can copy /bin/-- here. And right now, if I execute that, there's nothing too special about that. That's just the -binary. I can execute that, and that gives me that pretty little pound sign that everybody knows and that everybody loves and every hacker wants in their lives. So, what about giving it suid permissions? You could chmod u+s on dash, and then transfer that file and maybe traverse into it, right? And then execute it. And in some cases, if you can execute on that share, or you have read, write, execute, right? You can read, you can write, you can execute. If you can execute and your user and group match, then you can definitely exploit that remote weak NFS configuration. And I encourage you to look that up, maybe do some extracurricular studying on a suid sticky bit. Notice the little S there is different. Instead of it just being execute, it executes with UID = 0 permissions. So that would be a secondary way of even doing things with NFS. And with that, I'm going to exit out of this and go back to our notes here. Scroll to the top. And guys, my name is Siren here with Startup.Security. Hope you enjoyed this module in which we covered, what did we cover in this module? One, we covered SMB null sessions. We covered SMB null sessions, SMB guest checks on ports 139, 445. We also covered SMTP enumeration with SMTP user-enum. And we also exploited weak NFS configurations with a number of techniques. In addition, we also exploited weak SMB configurations with Samba, and achieved the ability to traverse the remote file system via symbolic link. And with that, guys, my name is Siren with Startup.Security, and I will catch you in the next module. Peace out.